So our next speaker is the CTO and a member of Nectar's founding team responsible for vision and strategy in the unified communications market with initial responsibilities for product development and management, engineering, pre-sales engineering, offer management and pricing. He will give us a presentation on SDN API and Unified Communications, and the subtitle being Enabling Visibility Across the Network from Service Provider to Integrator to End User. Please welcome Joe Fuccillo.
Testing. Thank you for having us. We joined the forum about a year ago, so it's our first time here. So thanks for having us and speaking opportunity. We thought we'd bring today some opportunities to view what we've been doing with this in the real world, and some case studies, and showing some applicability. And this is just to give you a sense of the type of companies we work with. So when we talk about experience in real-time communications, this is a quick sampling of some of the logos of companies we have insight that we work that use our software. We have a lot of insight. We in a unique position that we see millions and millions of call flows and records and diagnostics from all over the world. So it is helpful to see, and across multiple vendors, as you'll see. So the specific challenges that we've talked about here and experience is we starting with, let's make sure this didn't skip a slide. Okay, good. And Pascal hit the first one on the head. He stole a little of my point, which was VoIP strategies don't work here. We've had very specific strategies that we designed years ago. We knew exactly as he said. We know a traffic pattern. We know the codec. We know the engineering. We put on a VLAN. We could lock it down. And it was rough in the beginning. I mean, it wasn't no panacea out of the gate. It definitely vibrated quite a bit. And thank goodness for cell phones, because we would just say, no, we're on a cell phone. It's not a VoIP phone. And people, oh, okay. You're not selling me now, are you? No, this is a cell phone. The VoIP stuff is really good. And be like, oh my God. But no, it was much simpler. And in talking with colleagues, we talk about UC, and it's on their computer. It's on a separate VLAN. It's not a different device. They start and chat. Hey, can you talk? Yeah, okay, good. You know what? This is too complicated. I don't feel like typing. Let's jump on a call. And then someone said, hey, let's check the camera and turn video on. And we went from a couple kilobits to 40 kilobits to, hey, 1 meg HD, check out my new camera, right? And on the same device. So and when network engineers think about this, they go, oh, whoa, oh, yeah, okay, that's not good. So, so you go through this, and then, how do you handle, one of the challenges that the standards bodies could hopefully address is the fact that reporting and diagnostics information on the user experience is not standardized. Every vendor does something different. Some give end of call stats, some put in a CDR, some don't give any stats, some send them on our RTCP report. So as someone in the diagnostics business, we're kind of like a Swiss Army knife. We got to kind of figure out what is available, what's not available, how to augment it. So having some standardization would be very beneficial for everyone, including the end users. And then again, the application, as it should be, that layer 7 is kind of 4 layers away from 3, right? It doesn't really care about how it gets there, but it does matter. So having an ability to understand diagnostics and mapping is very critical. And as issues identifying, as Pascal said, again, time-consuming, armies of people, right? And if you look at what you kind of need to have in this space, and this is just in general, this is not vendor specific, but you need to have system health and availability. You start with the grassroots. Is the stuff working? You need to have a lot of good understanding. But what's also important, really important, is understanding dependent relationships. How does this user's ability to make an outbound call that goes from a headset to the computer to the local access or the wireless, through the network, to a call control, to a session border controller perhaps, or to a VoIP gateway, and think about all the pieces, and that's a simple call flow. What if you got an IVR or a contact center, and you got calls moving around screen? So the more dependent relationships, the more we automate and tightly integrate the communications experience with the user experience, it's very powerful when it works. And it's also very disjointed and very difficult for people to troubleshoot. Why didn't that happen? And one of the big challenges across this, and you'll see in the use cases, is departmental silos. A voice group, a network group, a desktop group, a server group. The user experience cuts right across them. Right? A lot of finger pointing opportunity between those different technology groups. Both you have technology, departments, and so forth. So performance then and capacity is very important, right? Resource utilization, pretty straightforward. Then you move into diagnostics and measurements. How do we measure quality experience? How do we know what's going on in real time? How do we have a real understanding of what a user's experience, and not an average, nothing's more frustrating than an average MOS score or opinion score at the end of a call. It was a 3.8. It wasn't a 4.2, it was a 3.8. No one's going to throw an alarm off. They had a 3.8, they're fine. The user says, terrible. It was an hour-long call. It was a 3.8 for the hour, but there was chunks of that call that were terrible. And the use of the user experience versus an average does not tell the story. So it's understanding that and having awareness of it. And then being network aware is very important. Being able to understand QoS settings, interface statistics. This becomes very much a big data problem. There's tons and tons of information and analytic statistics here, relating them, managing them, and then doing something with them. So what we try to do, and just in general, is if you look at the ecosystem, and there was a great point about the ecosystem from our friend from Unified about it's a very large ecosystem, and that's bigger than any one vendor. These are just some sample logos out there just to kind of put out that you've got existing environments, you've got new UC, you've got routed networks, SBCs, premise, Wi-Fi, headsets. All this works to provide the user experience. So if you don't have telemetry and diagnostics inside of here, that's why, as Pascal said, hours upon hours. So some of the traditional ways to look at this was, hey, we got network guys have lots of SDN API network management tools. They collect all this information. The level they collect it at is typically not really good for real time. They tend to look at 5 minutes. They look at things at a time slice that's an eternity for voice and video. There's raw wire packet. Hey, when things get ugly, you get the sniffer out, right? I'm a network guy. We get the sniffer out. We start doing packet capture, start ripping through those, and that's not easy to do. We got call detail reports. We've got port. So you look at this. At the end of the day, you wind up with people staring at doing swivel chair. Some guy's looking at this set. He's looking at this. They're running around each other. They're pointing fingers. Huge amounts of time to solve the problem. And it's manual correlation. So this is what the diagnostic cases are after to change. So if you look at an approach of looking at the different vendors and saying, hey, if I can get real-time information, I could use the link or Unified Communications. If I have knowledge, and if the existing environments, let me just build this out and it'll make sense, is doing things like using, and modern link is great, modern state-of-the-art has an SDN interface. We can consume that. What do I do in the legacy environments or other environments that haven't adopted it yet? So what we do is we use a probe, an analyzer, and we stick it on the wire, and we watch skinny signaling go on the Cisco side or SIP signaling so that we can understand call starts, call stops. I'd much prefer to be out of band off to the side and have something intelligent like the SDN API, but I can do it on the wire if you're willing to give me a tap or a span. But either way, I become aware of sessions. And we use the session awareness to then talk over to the network infrastructure side and look at, hey, what am I doing route topology-wise? So, again, diagnostic tool speaks routing protocols, BGP, OSPF, static routes, understands topology, pulls now signaling and topology together with statistics, able to talk to the gateways. And this is kind of the heart of the diagnostic end, is taking inputs across the board from all these different systems. And if you put it on a big complex picture, in a data center with SDN and environments and sites and branch sites, we talked about this build out, getting the UC signaling in, being able to have that insight onto the wire and looking at what's going on in campus and branches at the data center, pulling that type of information, and then combining it all together. So if you could have visibility. And then there was a great question earlier about what do you do for this conundrum here at the bottom? What do we do when you're going through a cloud that you have no insight into? It's hard enough to do this in the corporate controlled environment where when the IT, they have control of the upper right. What do you do in here when you have a network that you have no ability to control? And that's where we've talked a lot about mobility. And I mean, all the use cases here are about the growth from mobile on demand. So there has to be some work done here in order to improve, and also just make the user aware. And we use this analogy. You know, I'll take my cell phone. We all know, we look at the bars and we go, if you have to make an important call and you have no signal strength, you walk someplace else. You don't make the call. You know, the user sitting in the coffee shop should have a way of knowing he probably shouldn't do a video conferencing call there. You know, or maybe, you know, what's the experience going to be, in a way to have the application tell them, you know, a little smart. And if we can get a little smarter in informing the user, right? Because one of the bad things about, one of the good things, sidebars of technology getting better, is the users become a little less sophisticated too. Like they don't, my wife tells me all the time, she goes, just email me those pictures. I said, hon, it's a 20 megapixel camera. Each pic, I can't email you 25 pictures off the camera. Why? And just no concept, you know, they don't think, they never thought about storage and size. And no concept, just you got to, you know, it's just amazing how the user doesn't understand, and they probably rightly shouldn't. But anyway, so when we look at this, and to success would be, a big part is assessment. You know, pre-knowing what you're going to do. If you're going to bring someone into UC, being able to model the behavior, generate traffic, understand, do video calls, do these meshes, understand, is the network ready? You know, do I need to increase bandwidth? You know, and have a sense. And then health and performance, and then diagnostics. And if you don't get this right, as Pascal said, adoption's going to suffer. You know, we get involved in a lot of customers where we get brought in because it's not working right. And there's a lot, and we'll talk about some of those cases. So you've got to look at this curve, and it doesn't stop here. And then the analytics on understanding that if you do it really well and more people start using video and more people are collaborating, there's more application share going, the demands on the network are going to increase. So you got to understand, well, based on the way it's growing, where will I run out of capacity? You got to be able to project and understand that it's going to be. And then I think ultimately we're going to get down to policies, because you have to be able to control. You know, what if I have a condition where I can't meet both requirements? Who loses out? All right, so ultimately policy servers are going to come into play. So basically, if you put this all together, what do we get at this? We look at the ability to ability to peer at the networks. We talked about monitoring, reporting. You get diagnostic tools where you could do SIP ladder diagrams, and you can rip and understand, how did the session start or fail? Why did it? You know, there's some great cases here in the SIP questions about all those messages. Well, the user got a fast busy. What was the error handling that was sent back to the user when something failed in that negotiation? What did they get? Did they get a busy signal? Did they get, you know, what happened to the user if that fails? They get disconnected, and then how do they diagnose those? So being able to go back and look at that, that's why one of our concerns, I raised a question earlier about the encryption, is it makes diagnosing it very difficult, because I lose the ability to see some of the messages. So we've got to have a way in the standards to send to an analyzer that information, so that we can continue to have the ability to diagnose. This is kind of a, pretty straightforward what it delivers. And then what's the benefit of it? What happens when you do these? And what we're seeing is, hey, it's all about the customer, right? Client saves money, they get adoption, we're all happy, the market grows, and so forth. Because a lot of customers are skeptical today. And you have culture where the telephone guy says, they're almost looking for it to fail because they want to keep the status quo. See, I told you it wasn't ready for prime time. You got to get that trusty, and it delays, and then that takes a life of its own. Then people hear about it. One CIO tells another CIO, oh man, this thing was terrible. The next thing you know, we're years and years and dragging through adoption curves. So if the diagnostics is done, I'm not going to consider by going bullet by bullet point, but it really, in the end, it self-fulfills. You get happy customers. So thought we'd talk about two use cases that we've seen from two different customer environments. So this particular customer scenario was they made a decision, commitment to go with Link. It was 3,000 enterprise voice users, 300 locations, started the project, and multiple parties involved. And pilot went okay, started to roll out, started experiencing severe issues, project halts, comes to a stop. Poor quality, congestion, dropped calls, user experience is terrible. You know, when you looked at it, you had systems integrators, you had service providers and carriers, you had third-party data center parties and end users, and and going on for months upon months. We were actually brought in. It's about 6 months in the making of just complete finger pointing, everything halted. We came in, and the SDN API was probably hot off the press. Loaded it up, brought the API in, paired with the network. Less than a day, blaringly obvious things popped out. The end of the day, what was, how do we work? Well, SDN API. So we're talking to all the network routers, and we're getting the API feed, and we're pulling statistics in and QoS info and Q info and so forth. And ultimately, what we found was that, they swore up and down that the network was engineered for 40%. It wasn't. There was, QoS is difficult, and one device in the path misconfigured knocks it all out. And it wasn't set at 40%, set at 20%. There was rerouting going on to the data centers where Link was hosted. I mean, so this was within 8 hours of diagnostics. Within 30 days, they had 95% of their problems fixed. And this had gone on for 6 months. Because it was about being able to take all those data sources and put them together in context to, I'm having a bad experience right now, what's going on in that path right now, and then being able to pull that together. So the second one is a much more complex one. This is a regional hospital customer of ours network, and this was a mess. This was a storm. So what they have is they have a regional campus network, remote offices. It's all over the state of Connecticut. There was 20,000 plus VoIP handsets deployed, let alone tens of thousands of analog ports in hospitals and digital rooms and so forth. They had put 1,500 wireless ASCOM and SpectraLink phones out, and the people running around with those. They have well over 1,000 access points and buildings, controllers, very large network. And they had 500 people piloting, UC on a mobile device with the intention to go to thousands and not stop buying those hard devices. What we ran into was, what you have is the bottom line is quality experience problems to the user, right? We also had availability, had downtime, things dropping off, unexplained. You had a network team, a voice team, a desktop team. The network team had a subgroup for the wireless beyond just the network. The voice group had absolutely no tooling, so they were completely blind to what was going on. They didn't have any product at the time. The network team was using traditional SNMP tools. The Wi-Fi team had a strong set of RF management and tools that were provided by the wireless vendor. They had a pretty good idea what was going on in the air. And again, we go back to, it was it was chaos, and we sat in a room, and it was massive finger pointing on each other. And what came out of it said, what if we could show you which access point the person was connected to and what their statistics were during that call, and what access point they roamed to through the building during that call? What if we could put all that together so when you looked at their phone call, you could see where they were in the building, what their statistics were, as an example. And everyone went, that'd be great. If we could do that, and that's what the goal was. So we actually, at the time, we actually built a module. We didn't have that capability. We actually added the Wi-Fi support for this particular customer. And so at the end, what we were able to do was, because it was it was not like a link SDN. We used the signaling, the deep inspection, SIP signaling and so forth to get off the wire call starts and call stops. We integrated to the network with route peering, OSPF on their internal network. We then tied in all their real-time call statistics. We put a couple of audio analyzers, probes out in key spots. We incorporated the call detail records in. We integrated with the wireless network. And when we went up and we took, for example, if the wireless network, we identified all the Wi-Fi access devices and we cross-reference those MAC addresses and IP addresses with what's registered on the SIP signaling. So we can say, so of all these 10,000 wireless devices we see, these are the ones that are VoIP enabled because they are registered to the call control platform. And those are the ones we particularly paid a lot of attention to, where they were roaming to and pulling statistics out, signal to noise ratio, packet drops, retransmissions, 7 or 8 key statistics gathered. And then when they make a call, tie those statistics to the call detail record. So you can see when they made a phone call, where were they, and what the statistics were as they roamed around the building. And out of that, they were able to identify in the Wi-Fi, so there was a slew of problems. QoS issues, markings on the LAN and the WAN that caused problems on the underlying network. The wireless side was an interesting one because, at the end of the day, the network density was not set up for voice. They did a very good access coverage. And when the Wi-Fi study was done, they were accepting kind of, lowest signals as you roam from one access point to another because it was a data application. They didn't think about when they did that, someone would be on a phone walking through there and using it for voice. So they had to re-engineer the channel planning. They had to add additional access points, which caused the whole re-engineering of density in order to ultimately fix the problem. But they actually had to be able to look at calls and say, where do I have this problem? Which sites of the building is it in? And use that type of information. So lastly, I want to talk about, and then open up for questions, is where do we see the market going? And what we're focused on is there's some work we're doing with the headset manufacturers, because there's some great statistics now coming from the headset manufacturers and incorporating what the headset sees as quality at the ear. So it's saying ear to ear is what some things we're talking about, and understanding even how far their wireless headset might have gotten from the Bluetooth range, because sometimes we walk away and we forget. And it does create packet loss, but it's not in the network, it's in the headset. We see a great opportunity working with some of the session border controller vendors to look at how can we provide an SBC, as an example, real-time quality information about how call quality is being delivered downstream. And if there's a problem down in the network, can they reroute and go down the network? As Pascal talked about, network configuration, QoS tag info, being able to integrate. So we're looking at working with the various SDN controller manufacturers to see what kind of information, because now there's APIs for us to provide information on. So we have all this wonderful information. How can we then share it? With the goal being, how do you avoid if we could diagnose, this is all about automated diagnostics, can we avoid a bad user experience? If we, my analogy I give customers is if I know there's traffic on the road and I can't get down it, why would I want to send someone on a path they're going to kill? Can I reroute them someplace else? So can we provide advice either in the SIP network or on the data network to get around that experience? And we also think there's a big opportunity in universal call admission control, because ultimately, if I'm going to put my hand up to one application and say I need you to slow down because I'm going to let someone else through, I got to have a way to do that. If I'm telling the network to prioritize this versus that, I need to also be able to stop another system from creating calls, because so you need to really think about reaching in and changing a policy, whatever it is that you're giving priority to. So that gets back to the whole policy engine about who's going to put one hand up and wave the other one through. But that's a big piece. So with that, I want to thank everyone for your time, and if you have any questions, I'd be happy to field some.
One question. Thank you. I have this question, universal and dynamic call admission control. In my experience, this is the worst thing. You will never be able to handle that, probably, because hardware vendors don't like to give you insight, or they don't want to be controlled by the application. Mm-hmm. At least that's what was my experience in the last couple of years. And do you think there will be a change?
No, here's what I think. I think that This can't be accomplished traditional way, because in my opinion, none of the call control vendors, no one wants to cede control, right? Everyone's deathly afraid of giving control. So, and it's not, whether it's Avaya, Cisco, no one wants to let someone else take control of the call flow, because they feel if they lose control of the call flow, they lose control of the customer. They're not dominating anymore. So I don't think that's going to change. I really don't. I don't believe that I will see that type of cooperation. But I do believe, what we've seen here is we understand, as an example, what's going on in each system. You have an interface. So I could go into Unify, or I can go into Cisco, I can go into Avaya, and I can go on the command line with a web interface, and I could knock down settings or raise settings up. So you don't need to have everyone agree to do that. You need to have a piece of software that has enough insight into multiples, and then be able to say, and have a policy server that says what's more important, so that I could essentially dial down one through whatever interface that vendor has, and dial up the other to whatever interface that vendor has. And that's achievable today. And we see that as the path forward, because we don't see there going to be any way for a joint way.
But this will always be a kind of a best guess on the situation. So if you have a network which is kind of consisting of multiple kind of environments, then probably you will never have the real information.
Well, I would say that, at least for where we've developed modules for, we're in call flow. So our controller, our software knows every session on every one of those UC environments in real time. So if you come into our software and you look at a node for a given vendor, we'll tell you how many calls, how much network region bandwidth they're using, how many calls per second between sites are going in. We'll know what the network utilization is. So we're very much aware of what is going on. And we're pulling those statistics from your interface, from the given vendor's interface, and tracking. So in a sense, you have to make a third-party software like ours kind of take control. But we're think of us as middleware. We're developing interfaces into each one of those independent systems so that we can have knowledge of all, and then apply policy on top. And so where we do have that interface, we are aware.
Thanks.
No problem.
Maybe one more. Yes.
Thanks for a great talk. And after the various different SDN topics today, I understand the problem more and how SDN solves the problem. My question is kind of a larger one. The whole mobile industry is moving rapidly towards voice over LTE, which is just voice over IP, right? And if we believe the FCC, they're working towards a PSTN shutdown in 2018, replacing the whole thing with IP telephony. So are you saying that absent getting SDN deployed across all these various different systems, that voice and video communications are going to collapse under its own weight in the next few years?
No. We think that if you don't deploy SDN, I mean, these systems exist today. But we believe the cost of operating them and the cost to manage them in scale is significantly increased. And again, I think when you talk about voice over LTE, that's a very specific type of traffic that they're going to engineer for. It's very different if you're going to try to engineer for video and on the same device and with quality. So again, taking a very specific type of bandwidth and engineering for it, I think is very achievable, and service providers are. It's looking at the broader scale of what it takes a global customer to engineer thousands of nodes. And it's all hard-coded. And if you go in a network today and you ask what their policy, they're hard-coded QoS settings across thousands of devices. And if they want to make a change because they're growing elastic, someone has to go hard-code the settings again. That has to change for the customer to feel more comfortable rolling out these services on their internal network. And it's really the inverse funnel. It's the middle. If you think about the internet, it's the funnel on the ends is the problem. It gets big in the middle, and you got to manage the choke points more than the middle point. But the SDN, why the operators all into this? I mean, why is you took all the service providers? Because have enormous armies of people and cost to provision and maintain these big networks. So they're looking to drive the cost, that cost down dramatically. And SDN is the first time they've seen a viable technology that they could actually really implement and not use kind of legacy provisioning. Thank you.
Okay, thank you very much.